two guys, forgotten, blind spots. And I believe that the third force is really environmental adaptation. Now, you know, for 5 years, I had the pleasure of working with one of America's greatest ecologists, planners, environmentalists, by the name of Ian McHarg, M-C-H-A-R-G. And Ian, who went and taught at Khosrow School in North Pennsylvania, wrote a beautiful book called Design with Nature. It's a pivotal book. It's written by a man who understood ecology, who also understood simple ways of how you use this tool as a design tool. And we designed with him something that I'll just briefly go over tonight, and also entire new cities for 5 years. And he really taught me about environmental adaptation. And what I remember more than anything else, he said to me, Nader, environmental adaptation is about a very simple thing. Nature is very, very precise. And you have really only 3 things that it will do with you. You'll either adapt to nature and survive, or you will migrate from this particular natural setting to another one in which you can survive. You know, it's like a tree that, for instance, could not survive very well in this climatic zone or as climate changes, and trees migrate. Yeah. Human beings migrate. Look at us here. We've all migrated, sort of. Yeah. So you migrate to survive. And then what happens? What's the third one? Extinction. Extinction. Very ruthless. So the world today, when I was mentioning the issue of the greatest challenge being climate change, we have to know that we as human species, and that's what we are, we're part of the species of this planet, but we happen to be one of the most dangerous species, because really human beings are scavengers. We use up resources, and most other aspects of nature, bees, for instance, use up, but then they produce something that is then reused by something else. That is, recycling is an aspect of what nature does to survive. We don't recycle. We used to. I remember, you know, I think exactly the same forms that we would build for, let's say, an American culture. Let's say, an American culture from Las Vegas. And what do? We build it in Dubai. Dangerous. But this is the mindset of the problem, and why I say to you that sustainability is important, because it's not only important to build containers that are sustainable, but they have to fit the container, the people who would live in it, their ways of life, their signs, their symbols. Okay. So consequently, I found that if you're going to try to deal at the root level, you're going to have to deal with these 4 points. And here at this particular one, I want to say to you, I've had the pleasure of working with the greatest innovative engineers in the world, and I still do. And I've learned that innovative technology is one of the key issues, but innovative technology doesn't necessarily mean that it has to be artificial. It means, however, understanding the way and functions of things, whether it's natural ventilation, or it's air conditioning, or it's structure, or seismic, or etc., and to try to use it in the very best ways. And yet you might even invent innovative, complete new thoughts that allow you, for instance, to use, I don't know, a carbon fiber or other things. Yeah. Okay, so nobody's going to be an old fogey looking. You know, I want you to be completely at ease to use the latest technology, but to understand when it's appropriate. So when you do these 4 things, I believe you may touch on what I've learned, luminous design. Why luminous? Because within this culture, you touch on something also poetic. So there are certain architects that have this quality in the work that they've done. where the building is inspiring. It's not just, that it sells. That then builds up toward the corner, and so that you could even get an architecture of 20 of some stories and build down to 7, 8, and even 2 or 3 stories. And high density, high compact, mixed use design that's yet still very modern. And I'd be very interested for you all to experiment on your site. And your site, you may decide that you want to do medium density, so you might get around this. Some of you might say, no, I want to actually push the envelope and get high density. And that's why I have some numbers in here. How many people per acre or so you have to get onto it. And I'm going to try that with you. But really everything, and I'll talk more about the principle of it, is based on the idea of a courtyard. Now I know that really we don't do courtyards in Oklahoma. We've got ranch, no? We did the log cabin, we went out there and the log cabin became the isolated form. We had to do isolated buildings. And so really we have little isolated objects with space around, where this is just the opposite. The space is inside and the container is around. And then you can butt these guys up next to each other really, because really this is what creates the event of private space, ventilation, etc. by the means that I've shown you. So another thing I want to introduce to you, which may be a new concept to you, and you may actually say, no, I know of the courtyard in such a place and it works very well. I want you to think courtyard. But then you can also do courtyards like this. So that was the courtyard there, and then that's the next one, that's the next one. So it's wonderfully creative. You can put things next to each other like a jigsaw puzzle. And the space is all inside. And you can get a new architecture. But it's very dense, it's very sustainable. Why? Because it has very little exposure to heat gain. So instead of building this, which gets heat from all sides, you build this, which gets almost no heat gain. It's all contiguous, very little surface. And in a desert, the ideal is minimum external surface to maximum internal volume. What does that mean? That means you build something in which the surface that gains heat is the least and you have most volume inside. What is that as a shape? It's a ball, it's a sphere. The sphere has a minimum external surface, maximum internal volume. That's why nature creates apples and bubbles and So you're just following nature. Okay, now if you apply it to architecture, then it means you do interiorize things. That's very good adaptation. But interiorize things like this guy, which is not naturally ventilated, is a little bit tough. You get sick. But if you do interior things, which you bring in natural ventilation, it becomes quite interesting. So that's what I want you to keep thinking. And then as I'm growing this, you can see that you can actually create a very exciting variety. Parts of it actually can become great gardens. And here are examples of various things that people are doing here who've got commissions to do buildings. I'm just going to go very quickly through these. Now I'm going to show you this thing by Norman Foster. That one, last one, by the way, was really designed in many ways by a group whom you may know, engineered by Arup, A-R-U-P, one of the great English engineering firms, or outstanding firm of the field of sustainability, and an American firm called AECOM, one of these huge conglomerates that is now, I think, 50,000 people around the world. I can't believe it. We had difficulty running a 30-man office. But in Abu Dhabi is another experiment called MASDAR, M-A-S-D-A-R, a carbon-neutral city by Foster and Partners. And we've had the good fortune at Harvard with our research to really meet with these people, meet with their designers, know intimately what they're doing. And here again is very interesting. Look at this 1.5 kilometers. What is kilometer and a half in miles or feet? Two something miles? 1.1. let's say 2 miles by 2 miles, something. And it's a house, it's a city for 50,000 people. It's a courtyard city, all based on the same idea of compact courtyards. And all the parking is on the outside. And then people move through it really by a means called personal rapid transit. It's like your own little car, which is all digitized and computerized. You get into it like an elevator. You know, you get in, you push floor 5. Here you get in and you push horizontally, I want to go to X. And you move around with PRTs. And then you can connect to a larger unit that then connects you to the city. So really, there's no cars in here. And there are different things. And there's a university in here, and there's housing, and there's a city center, etc. And so this is another experiment. It looks in side angle like that. But nothing here is more than 4 to 5 stories. So I want you to think about something that is of this nature in the work that you do. And when you're inside, long, tall, narrow, shadowed, and the entire roof is all solar voltaic panels. So the first thing about this city is that compared to other residential cities, this uses 50% less energy. So instead of using this much energy, this uses this much energy. Why? Because it's protected with that same idea of shadow, so it doesn't gain the heat of the sun. But the clever thing is, while this guy gives me shade, this side catches the sun, and it becomes a solar panel, and it produces about 25% of the energy that this town needs to run. Oh my God! What an innovation! I want you to do things like that. I want you to think like that. And a great firm, Adrian Smith, who led a lot of the work at SOM, also designed their headquarters. And here you see a very interesting thing where this all is based on how you can actually get natural ventilation moving through what is the headquarters for this town. And great roofs, and then all the roofs again are all photovoltaic. Or great tents that at night close up, and during the day they open up to give shade, and the rest of the roofs are again all photovoltaic. Yeah. I want you to do some things like that. Think about things like that. Now, in the 1970s, when we were slightly younger, you guys were not here, America was the leading center for solar energy design. We all belong to the American Solar Energy Society. We designed, and I'll show you, an entire solar energy city I designed in 1979, first one in the world. Yeah. And however, when oil got cheap, all this stuff got shifted away from America and went to Germany and Japan. So Germany today is the leading sustainable energy guru of the world. And Hans and